So, a very good afternoon to all. My voice is audible to all of you. Confirm me once. And my screen is also, I guess, visible to all of you, right? If you face any problem, then you can just text me. Or everything is right, then just confirm me so that we can start our today's session. Clear है सब? चलो ठीक है. Good. Yes. Yes, JNV Simoga, you want to say anything, beta? Yeah, just show your present. Okay, chalo. ठीक है. So this is the recall test for all of you. This is based upon the electrochemical reactivity series. ठीक है. So this is from the reactivity series. So can anyone tell me the correct answer for this? So we studied reactivity series yesterday, right? This is the reactivity series, right? On moving down the group, the electron reduction potential become positive and the oxidizing property is increasing. Similarly, when we go above hydrogen, that is from hydrogen to lithium, then reducing character increases. मतलब जितना ज़्यादा negative होगा, उतना ज़्यादा वो reducing character होगा. Or if they having more positive electrode potential reduction potential value, it means they are oxidizing nature. ठीक है? So just on the basis of this electrochemical reactivity series, can you just tell me the answer for this question? फटाफट within 1 minute जल्दी से बताओ. Then we are going to start the today class. That is D. Okay. एक ने D बोला है. Anyone else? Oxidizing power. Beta, oxidizing power means electrode potential having reduction potential value having maximum positive value, right? So if you say option D, then Bi plus 3 having electrode reduction potential value only plus 0.20 volt, where CO3 having 1.81. So CO plus 3 having more, na? So D option is not correct one, right? So this is not the correct. Okay, JNV Dhadod ne bola hai P. Okay. So let me check whether the option B is correct or not. So CO plus 3 having value 1.81, very much correct. After this, we have a PB4. So PB4 1.67, then CE plus 4, very good. Then BI, very good beta. So option B is absolutely correct. So जिन बच्चों ने भी option B बोला है, वो बिल्कुल ही सही है. ठीक है? So that is option B is absolutely correct. वो शायद जिसने D बोला है वो शायद ये देखना में थोड़ा सा उसको कंफ्यूजन हो गया होगा. ठीक है सिंबल में. तो इट्स ओके, नो वरीज. चलो, सो वेरी गुड, सबने सही जवाब दिया है बिल्कुल. सो दीज आर द ऑक्सीडाइजिंग पावर ऑफ दिस बेसिस. दे आर द इंक्रीजिंग ऑर्डर इज लाइक फ्रॉम Bi+3 to CO+. चलो, now very important topic of the electrochemistry chapter is the Nernst equation, right? So this Nernst equation is very important topic, right? And you must know how will you write the Nernst equation. So basically, what is Nernst equation? Nernst equation is also used for the calculation of the EMF of the cell. But why Nernst equation comes into the picture? Basically, we know how to calculate the potential of the cell. We can calculate a standard reduction potential of the cell by just E cathode minus E anode. We know the formula. But why Nernst equation comes into the picture? Because this standard EMF is valid only when the concentration is 1 molar, when the temperature is only 25 degrees Celsius, when the pressure is only 1 atm. But everywhere this condition is not necessary to be present, right? Somewhere the temperature may be varied, somewhere the concentration may also be changed where you need to calculate the cell potential or voltage. So only standard condition are not feasible always, right? So Nernst equation are used to calculate the EMF of the cell for the those condition in which the concentration is not equal to 1 molar, the concentration may be 2 molar, the concentration may be 0.10 mole, right? So this Nernst equation give the wide range of calculation, right? So ये हम लोग का क्या है? They are the improved form of the electrode potential calculation, right? So a relationship between the electrode potential and the concentration of the solution is called the Nernst equation. Now for the general, basically for the general half reaction, what do you mean half reaction beta? For the general half reaction means if we have that is Mn plus, right? We have Mn plus in aqueous. So this is metal in aqueous and they accept one electron, that is number of electron, Ne. So they convert into metal solid. Right. So this M having plus N charge, they accept plus N electron to become Ms solid. Now, how will you write the Nernst equation for the following compound? So we can write the Nernst equation for the following compound like this is Mn, right? Mn to M. Done. So this is Mn to M. So this is the expression for the Nernst equation for this metal, right? So we'll write as E naught. E naught is the standard electrode potential. E naught, that is Mn to M. Okay, that is Mn plus 2M, Mn plus 2M minus 2.303 RT divided by NF. And this is nothing but log concentration of the concentration of the Ms. So we can let me write the first thing. Then after I'll going to explain this. That is Ms and the concentration of Mn plus. Right. So we know that in case of solid, right, the concentration of the solid phase is taken as unity. This thing we already studied in the equilibrium chapter, right? That is the concentration of the solid phase or pure liquid form always taken as unity. So this equation becomes, ये इक्वेशन किस में कन्वर्ट हो गया बेटा जल्दी बताओ, that convert into Mn plus 2M, ठीक है, Mn plus 2M, ठीक है, and minus 2.303 RT divided by NF, and this is log 1 divided by Mn plus, ठीक है, that is Mn plus. So this is how will you write the Nernst equation for the half reaction. Clear? So this is how will you write the Nernst equation for the half reaction. Done? Now, similarly, if in both the half cell, the number of the electron are not same, so we can also write as like the formula for the redox reaction. EMF of the cell is equal to E naught cell minus 2.303 RT divided by NF log Mn plus upon Mn plus aqueous, right? Where X and Y are the stoichiometric coefficient of M dash and M in the balance equation. Now, very interesting thing, we don't need to remember this a long formula because we know this thing, we know the value of R, right? We know the value of R and most of the reaction rate considered at 25 degrees Celsius only. So if we know the temperature as well, if we know the temperature 25, we know the R and we know the Faraday constant, that is 96,500. Then we put all these values, then we will get this standard formula, right? So this standard formula we are going to use, right? So this is the standard formula of the Nernst equation we are going to use while solving numericals. क्लियर है सबको? EMF of the cell is equal to E naught cell minus 0.0591 upon N. What is this N, beta? This N is the number of electron that will takes place in oxidation and reduction. So we are going to see this while solving numericals, right? And this is log product concentration upon my reactant concentration. Clear hai? Everyone, just confirm me once. Is it clear to everyone or anyone having any kind of doubt till? You want to ask anything till? Or is it clear? How will you derive the Nernst equation? You just need to remember the formula, right? That what is the formula for the Nernst equation? जल्दी बताओ, एक्सप्लेन करो फटाफट. क्लियर है? चलो. Now, let me quickly do one concept-based question upon this. So we have the electrode potential for the magnesium electrode varies according to the equation that is EmG plus, this is the Nernst equation, right? EmG plus 2 to mg, E naught cell of mg plus 2 to mg 0.059 upon 2 log 1 upon mg2 plus. And the graph of EmG plus 2, that is the electrode potential versus log mg2 plus, that is the concentration of the reactant or product is given, right? So which of the following graph is correct? So you have to identify the which of the following graph is correct for this. Can anyone explain me? So if you compare this equation, this one, right? This equation, what you observe, beta? You observe this equation is similar to the straight line equation, like y is equal to mx plus c. Will you observe or not? Which is the equation of the straight line? So the graph versus, in case of y, we have EmG. So in case of y, we have EmG plus 2 to mg. ठीक है? I got one response, that is A. Okay. A बोला एक बच्चे ने. Anyone wants to say anything else? So in case of y, we have this. What is the slope of this curve, Visa? Can you tell me the slope? And what is the x-axis? So this is the C, mx, right? So this one is the mx, right? This is the x. That is 1 upon mg plus 2. Okay, 1 upon mg plus 2. So can anyone tell me which graph is the correct one? A, B, C, or D? So this is not the straight line curve. So this will incorrect, right? This is incorrect. And this is a straight line curve. This is also a straight line curve. And this is a straight line curve with the negative slope, right? With the negative slope. So which of the following is the correct? Jaldi batao. In this, we have a slope of 0.0591. Let me explain this, right? We have, in case of M, we have minus 0.059 divided by 2. Now, this is log 1 upon mg plus 2. Here in all the options, we have log mg2 plus, log mg2 plus, and log mg2 plus. We have only, so we have only log mg2 plus. So we don't have any option of log 1 mg2 plus, right? 1 upon mg2 plus. So we can convert now log mg2 plus. How will you convert? So we can write this like this will become log, and this will be like mg plus 2, and that is minus. So log having the property this minus and this minus become positive. So this will become positive 0.059 divided by 2, and this is log mg plus 2. Okay? And this is the concentration term, that is intercept EmG plus 2 to mg. So now you compare the graph. So this is the M. This is the positive slope we have M, and this is the X, right? And this is Y. And this is Y. So which curve is correct? Tell me, which curve is correct, beta? Y is equal to mx plus c. If you want to consider which curve is the correct one. We get y is equal to this. So yeah, y is equal to this. We got x is equal to log mg plus 2, log mg plus 2. And the slope is positive. So this one. And this is the intercept, right? This is the intercept. That is E naught mg2 plus mg. So this is the intercept, right? And this is the straight line. If the slope is negative, then this graph will be correct. If the slope is become 0.0591 negative, then this graph is correct. Otherwise, this option B is correct. So everyone got it? Why option B is correct? Just if anyone having any kind of doubt, please raise your hand or ask me. सबको समझ आ गया? Why option B is the correct answer for this question? Got it? चलो. ठीक है? Now, similarly, by using the Nernst equation, you can also determine the pH of the solution, right? So for determining the pH of the solution also, we can use the Nernst equation. Okay? So determination of the pH of the solution. So how will you determine the pH of the solution? By simply using the formula, we know that E cell, EMF of the cell is equal to E naught cell, that is the standard reduction potential of the cell. Standard reduction potential of the cell minus 0.0591 divided by what, beta? That is divided by n. Divided by n, and this is log concentration of H plus. Right? Log concentration of H plus. So we can also, we can also calculate the pH, because what is pH? pH is nothing but minus of log of hydronium ion. So we can also calculate the pH by using the Nernst equation. Okay? That is the EMF of the cell is equal to EMF naught of the cell minus 0.0591 upon n, and this is log H plus. So I hope this is clear to all of you. सबको clear है? चलो. So on the similar basis, if you have a question like calculate the potential of the hydrogen electrode in the contact with the solution whose pH is 10. Can anyone calculate this by using the simple formula like this, right? So we have E naught cell. We know that E naught cell for the standard electrode potential for the hydrogen is always 0, right? So this value having 0, right? And this is minus 0.0591. And what is N beta? What is N? So we can calculate the potential of hydrogen electrode in the contact with the solution whose pH is there. So just put the formula. Log hydronium is equal to nothing but pH, negative of pH. So just put the value, you will calculate the E naught of the cell. So I hope this is very simple question. So this is the homework question for all of you. Just note this question and try to solve this question and calculate the value. ठीक है? बहुत simple question है. Just using the formula, you can easily calculate this. ठीक है? हो जाएगा कैलकुलेट, और मेरे को कैलकुलेट करना पड़ेगा. You want solution for this question, or you can calculate itself. चलो मैं सॉल्व कर देता हूं एक बार, because some of the student maybe face some problem, right? So first of all, let me write the equation, right? So for the hydrogen electrode, we know that D. Okay, D बोला है बच्चे ने. अभी चेक करते हैं बेटा, या D is the correct answer. अभी चेक कर लेंगे एक बार. So we know that this is the H plus. They accept one electron to become 1 by 2 H2. D, very good beta. 1 by 2 H2. Now, what is the EMF of the cell? So EMF of the cell is nothing but E naught cell, which is equal to 0.0 volt for the hydrogen, minus 0.0591 upon N. What is N here? N is nothing but 1. And what is this? That is log hydronium ion concentration. That is H plus. That is H plus. So the value becomes 0.00 minus 0.0591 upon 1, and this will be log hydronium ion negative. This negative become positive. So the value comes out to be 0. Yes, that the value comes out to be 10 log 10, right? The value of concentration is given now, 1 upon H plus, whose pH is 10. So 1 upon H plus is known as pH. pH is always given, that is 10 raised to the power 10. So just put the value. So 0.0591 into 10 log 10, right? Log 10 having value 1. So on solving, you'll get 0 point minus 0.591. So yes, option D is absolutely correct. Okay? So option D बिल्कुल ही correct. Now, let's see the second thing, that is the Nernst equation for the concentration cell. So what do you mean by this term concentration cell? Right? The cell in which both the electrode are of the same type, but the right? But the electrolytic solution have the different concentration are called concentration cell. Right? The cells in which both the electrode are of the same type. So electrode same होंगे, like zinc electrode, copper electrode, of the same type, but their electrolytic solution have the different concentration. One having some different concentration, one having some different concentration. So they are called concentration cell, right? For example, when the electrode is reversible with respect to cation, right? So this is the first case. That is when the electrode is reversible with respect to the cation. So we have a Zn plus 2. Then the concentration is C1. Similarly, we have a Zn2 plus and Zn, and they having the concentration of C2. Now, what is anode? So at anode, the oxidation takes place. So zinc loses 2 electron, right? And their potential is given 0.76 volt. At cathode also, they gain 2 electron. The electrode potential is given minus 76 volt, right? So the overall reaction becomes Zn plus 2 to Zn plus 1, and the EMF is equal to 0. Standard reduction potential is 0 because two same electrode are used. So we know that whenever the two same electrode are used, then always the electrode potential is 0. So what is the E cell? So E cell of this concentration cell is nothing but is equal to 0.0591 upon 2, and this is log C2 by log C1, where E naught value is 0. So always remember, in case of the concentration cell, the standard reduction potential value is always 0. Thus, we can say that for the reaction is to be spontaneous. Why we say the reaction is to be the spontaneous? Reaction is to be spontaneous means E cell value comes out to be positive. For the E cell value comes out to be positive, always the concentration of the C2 must be greater than C1. So this is what happened in case of the concentration cell. Is this clear to everyone? You got it? What do you mean by the concentration cells or not? Or anyone having any kind of doubt in the concentration cells? Remember only two things in the concentration cell. Both the electrode are of the same type, but with the different concentration, right? C1 and C2. Okay? So बस इसको याद रखो. Now, when the electrode is reversible with respect to anion, here electrode is reversible with respect to the cation. Now here the electrode is reversible with respect to the anion. So here we have a chlorine and chlorine negative ion and chlorine 2, right? So in this case also we have a E cell is equal to 0.591 upon 1, C1 upon C2. So for such case, cell reaction is spontaneous in forward reaction if only C1 is greater than C2. Right? If only C1 is greater than C2, then only this will be happen. Clear? Hai? Chalo. Now, the next thing is when the electrodes at a different concentration are dipped into the same electrolytes, right? When the electrodes at the different concentration are dipped into the same electrolyte, that is platinum H2 and HCl, platinum H2. Two half cells are joined by the two salt bridge since they have the common electrolyte. Okay? So at anode, we have H2, they loses 2 electron. At cathode, they accept 2 electron to become H2. So remember this case, when the electrodes at different concentration are dipped into the same electrolyte. So this is just the reverse of the first case. Here, the concentration, okay? Electrodes at the different concentration are dipped into the same electrolytes. Clear? Chalo. So here E cell is equal to E naught cell minus this. E naught cell again here comes out to be 0. So cell reaction is spontaneous in the forward direction if the P1 of LHS, that is the pressure of the left hand side. Left hand side means what, beta? That is the anode part, is greater than the pressure at the right hand side. Then only the cell reaction is spontaneous. So these all are the different cases of the Nernst equation. Now, this one is also very important one. That is the equilibrium constant from the Nernst equation. that how will you find the equilibrium constant from the Nernst equation. Okay, chalo. So basically for the general electrochemical reaction, that is AABB gives us CC and DD at equilibrium. What will happen? At equilibrium, EMF of the cell is zero. Obviously, at equilibrium, the EMF of the cell is zero, right? And we know that what is Kc, that is equilibrium constant. So we can write the expression for the equilibrium constant is like concentration of the product raised to the power stoichiometric coefficient. So that is C raised to the power C, D raised to the power D, and similar A raised to the power A and B raised to the power B. This is nothing but K. Now, therefore, we can write Nernst equation as, because we know that E cell is equal to E naught cell minus 0.0591 divided by N, and this is log Q, right? So here Q we have a Kc. At equilibrium, E cell is equal to 0. So if this quantity is 0, we can write now E naught cell is equal to 0.0591. Exactly the same. So we can write E naught cell is equal to 0.0591 upon N, and this is log Kc. So this Kc is known as equilibrium constant. So this is a very, very important reaction which connects the equilibrium constant and the EMF of the cell. Okay? So this is how EMF of the cell and the equilibrium constant are related to each other. Okay? Chalo. So we have a very simple question related to this. Try to solve this question. So consider the following half cell reaction: chlorine negative 1 mm and HDCl2 Hd liquid and Cl saturated HDCl2 Hd liquid, right? And E naught cell and EMF of the cell is given. What is the concentration of the Cl negative in the saturated solution? So you have to calculate the concentration of the Cl negative, right? So can you calculate the value for this? So we know the formula. What we know the formula, beta? We know the formula for the EMF of the cell. That is EMF of the cell is equal to standard EMF of the cell minus 0.0591 divided by N, right? And that is log Q. Okay? Now, for the particular reaction, can you calculate the number of electron? So let me write the equation so that only you can able to calculate. So what is the half cell reaction? So half cell reaction is like, this is Hg2 and Cl2. So they accepted this 2 electron to convert into 2 Hg plus a Cl negative, that is saturated. Saturated. 2 Cl negative, we can say further, 2 Hg plus 2 Cl negative. So here we can say that N is nothing but N is 2. Okay? So N की value तो 2 मिल गया. What is Q? So Q is equal to concentration of the product upon reactant. So in the reactant side, we won't have any ions, right? So only we have on the product side only, that is 2 Cl negative. So we can write as E cell value, we know. E cell value is what? That is 0.244. Clear? And E naught value we also know, that is 0.270. And this is also know 0.0591 upon N. What is N? So N is nothing but 2. And this is a log. What is Q here, beta? So Q we already calculated, it is Cl negative concentration. So you need to calculate the concentration of the Cl negative only, right? So only you need to calculate the concentration of the Cl negative only. So I hope you can calculate. On solving, you'll calculate the value. I'm just write the final reaction. So if you want to calculate the value of this chlorine negative and right. So if you want to calculate the value of this chlorine negative, what the value you'll get, beta? You'll get you can also write now this chlorine 2 negative as let me write in one step code, right? Like 0.270 minus 0.0591 divided by 2 into 2. And this log chlorine negative concentration. These two cancel, right? So on solving, you'll get the chlorine ion concentration. Clear है? समझ आया क्या सबको? कैसे कैलकुलेट किया? How will you calculate it? समझ आया सबको? जल्दी से कंफर्म करो फटाफट. Is this clear to everyone? JNV भावनगर, JNV औरंगाबाद. JNV शिमोगा, जल्दी बताओ बेटा. Is it clear to everyone? Right? So this is how you can actually calculate the value. So just remember the formula. If you know the formula, if you remember the formula, then you can easily identify which formula you are going to use, right? So if you know the formula and you know what the values are given, then you can easily solve such type of questions, right? This is this is the crash type of course that I'm going to focus more on problem solving, right? So try to solve question as much as you can. Now the next question, this question is coming in JEE Mains 2020. So what the question asks basically? So in this, given that the standard potential of copper 2 to copper, copper plus to copper are already given, that is 0.34 volt and 0.522 volt respectively. Now you have to calculate the E naught of copper 2 to copper plus. So these type of questions are very common questions, and you can say in every year such type of questions were coming, right? So how will you solve such type of questions, right? कैसे solve करोगे फटाफट जल्दी से बताओ. How will you solve such type of questions? You have given that the E naught of copper plus to copper and copper plus to copper are given, right? So if you know that is copper plus 2 to copper, this is the reduction takes place and the value is given like 0.34 volt. Clear? Now similarly, copper plus to copper, this is also the standard reduction potential value and is given as 0.522 volt. But in this question they are asking, how will you calculate copper plus 2 to copper plus, right? So this is how you have to calculate, that is copper plus 2 to copper plus, right? What is the change in the reduction potential value? So basically, we know this, we know only very, very simple reaction. What do you mean by this plus 2 charge? Can anyone explain me? What do you mean by this plus 2 charge? This is the oxidation number, right? So here what takes place? Reduction takes place now. This is the reduction takes place, right? So this is nothing but the reduction takes place. That is copper plus 2 to copper and copper plus 2 copper. So this is the reduction. Now they are asking what happened to the electrode potential if they have reduction from not plus 2 to 1 or 0. They have asked what is the reduction takes place, what is the value of the electrode potential when the reduction takes place between copper plus 2 to copper plus 1. So we know that the value is given as 0.34 volt and 0.522. Clear? So what is the correct option for this question? Can anyone explain me? Can anyone? कोई बताना चाहेगा what is the correct answer for this question? Yes guys? Participate karo. Participate is most important. फटाफट. No one? You have to calculate the reduction potential value for this particular reaction, that is copper 2 to copper plus. No? Chalo. Let me solve this question. We know this very simple thing. We know that is copper plus 2, when they accept 2 electrons, right? They converted into copper. And the E naught value is already given. E naught value is given like 0.34 volt. Clear? Now, on similar basis, when the copper plus 1 accept 1 electron, they also convert into the copper solid and the value is given. E naught value is nothing but 0.34 0.522 volt, like 0.522 volt. Now again, when copper plus 2, copper plus 2, when they accept only one electron, not two electron, only one electron, they convert it into copper plus 1. Clear hai? Copper plus 1, and their value is what? यही तो calculate करना है. This is what you need to calculate. This is x, right? This is x. So how will you calculate this? So we know from the equilibrium chapter in 11th class also, we study this thing in the thermodynamics in the equilibrium part also. We know that, what we know beta? We know that delta G is nothing but is equal to minus N F and E naught cell, right? This is the formula for the Gibbs free energy. This by using this formula, we predict the spontaneity nature, whether the reaction is spontaneous in nature or not, right? To obtain the E naught required equation, just subtract this value, right? So how will you write this beta? So we can write now delta G naught, right? That is delta G naught. What do you mean by this G naught? G naught means at standard condition. So there is the significance of this naught. Naught means standard condition. Always remember beta. So that is delta G naught of the third. This is the equation number 1. This is equation number 2. And this is equation number 3. Right. So delta G naught of equation 3 is equal to delta G naught of equation number 1 minus delta G naught of equation number 2. Just put the value. What is N for the equation number 3 beta? Can anyone tell me what is N? Yes, participate. What is the value of N here? Yes, JNV Jamnagar, JNV Anand, JNV Bahraj. What is the value of N in third equation? What is the value of N? Number of electron, that is. JNV Kolhapur, can anyone wants to say anything? What is the value of N in equation 3? Yes, that is 1, right? That is 1. So this is equal to minus 1. We are using the formula minus NF E naught cell, right? F is similar to F because F is cancelled in each of the given problem because F is common, right? So F is F. And what is E naught cell? So it is not given. It is supposed to be X. This is what we need to calculate. Now, similarly for the delta G1. So for delta G1, what is the value of N beta? So here the value of N is 2. So here we have the value is like 2 F and the value is given like 0.34 volt. Similarly, in case of the second equation, we know the N is, what is N? N is 1. That is minus 1 into F into 0.52. Clear है? Now, अब क्या इस x को कैलकुलेट नहीं कर सकते हो? बिल्कुल कैलकुलेट कर सकते हो. We know all the values. We know all the given quantities. F cancel out each other because F common आ जाएगा, right? And we know the value of EMF of the equation 1 and equation 2. So we can easily calculate this value x, right? So the calculation is very easy. अब कोई मुझे फटाफट बताएगा कैलकुलेट करके what is the correct answer? On solving, what you will get? On solving, what you will get? Yes, that is 0.158 volt. So this is the EMF of the copper plus to copper plus, right? Copper plus 2 to copper plus 1. So this is the amount of EMF change. So which option is correct, beta? 0.158. That is option number B. So option B is absolutely correct for this. Clear hai? Anyone having any kind of doubt? You can ask. फटाफट. किसी को कोई भी डाउट है? जल्दी पूछो फटाफट. No? Chalo, perfect. Okay, the next question is, this question is also very, very, very important. This question also come in the JEE main examination 2020. That is an oxidation reduction reaction in which electron are transferred have delta G naught. So they have this question is a numerical based question, right? That is a numerical based question. So delta G value is already given. You have to calculate the value of E naught, right? So you have to calculate the value of E naught. Can anyone? कोई calculate करना चाहेगा? This is very much similar to the previous question. Same formulas we are going to use. That is delta G naught, right? So can anyone? I'll give you a 30-second for this question. I'm waiting for your responses, right? The formula is very much similar. That is delta G naught is equal to minus NF and E naught of the cell. Fine. So just calculate the value of E naught cell. फटाफट जल्दी से calculate the value of E naught cell in volt, right? I'll give you a 30-second. ठीक है? Just calculate the value of E naught cell. Yes, Rushika, you want to say anything? Yes, all of you, please try the question. Try to solve this question. Try to solve this question step by step. First of all, find the value of n. What is n here? Then find the value of f. What is f here? Right? And then E naught cell. F is already given 96,500 coulomb, right? Calculate. So this is an oxidation reduction reaction in which electrons are transferred has delta G is given 17.37 kilojoule per mole at 25 degrees Celsius. The value of E naught cell in volt is dash into 10 raised to the power 2. Just calculate the value beta फटाफट. Here one data is also given, that is number of electron is equal to 3. Now you can calculate. Yeah, delta G is given now, that is 17.37. Here the value is in kilojoule. So for the kilo, we multiply with 1000. Okay. Now this is minus. What is N? N is given, that is 3. What is F? That is 96,500. And this is E naught cell. This is E naught cell. So we need to calculate this E naught cell only. This is a very simple question, guys. So E naught cell is nothing but is equal to 17.37 multiplied by 1000 and divided by what? That is 3 into 96,500. So on solving, what you will get? Just solve this. So this 2020 get cancelled, this 10 and 965 get cancelled. So on solving, what you will get beta? That is nothing but minus 0.06. So is this the correct answer? Is this correct answer? Can anyone? Is this correct answer? No, because they are asking in 10 raised to the power minus 2. So you have to provide answer in this following way only. So how will you write this 0.06 into 10 raised to the power minus 2 beta? So we can write as minus 6 into 10 raised to the power minus 2. So what is the correct one? That is 6, right? So this is the minus 6, right? So we can say that minus 6 is the correct answer. So this is the numerical based question. So these type of questions are also coming, and it is a very simple question. It's totally formula based question, totally based upon the formula. You just need to remember the formula, need to solve these questions. And one and most important thing, always read the question very carefully. ठीक है, बहुत ध्यान से पढ़ो क्वेश्चंस को, बिकॉज यहाँ भी आंसर, ये भी आंसर सही है. This is also correct, 0.006. But they are asked a question like this in the following pattern, that is 10 raised to the power minus 2 only. So always read the question very carefully. Then only you get the correct answer. Okay? Chalo. Now, what is the relationship between the cell potential, free energy, and the equilibrium constant? So we already know the one relation, that is delta G is equal to NF E naught cell, right? We already know this. We already know this delta G is equal to 2.303 RT log Kc. So if you combine these two formula, then we'll get the formula like E naught cell is equal to nothing but 2.303 RT NF upon log Kc, where N is always the number of moles of electron transfer in the balance equation for the process to which you apply the Nernst equation. Clear? Now, on the similar basis, you are going to solve one more question, that is given the equilibrium constant Kc for the reaction, and you have to calculate E naught cell for this reaction, right? So you have to calculate the E naught cell for this given reaction. Okay? So you are provided with the equilibrium constant, Kc is already given. Okay? For the particular reaction, sorry, you just need to calculate the E naught cell for this reaction. Okay? फटाफट calculate करो. Which formula we are going to use in this question? Can anyone tell me? Can anyone tell me which formula we are going to use in this question? Yes, JNV, Shimoga, JNV, Jamnagar, JNV. Yes, beta. Which formula we are going to use in this question? That is the relationship between the equilibrium constant and the Gibbs free energy. Because given the equilibrium constant, Kc is already given. You have to calculate the E naught cell of this reaction. Okay? And 2.303 RT of F is already given 0.0591. So you already know this thing, right? So according to the Nernst equation, let me solve this question. So according to Nernst equation, Nernst equation. So what is the formula for writing the Nernst equation, beta? We know that? Yes, that is E cell, EMF of the cell is equal to standard EMF of the cell minus 0.0591 N, and this is log Q. So this is the standard formula for the Nernst equation. Now, for Kc, we know that at equilibrium, so at equilibrium, EMF of the cell becomes 0, and this Q become Kc. This Q become reaction quotient become equilibrium constant, that is Kc. So this Q become Kc. So how will you write the formula now again? So we can write formula as E naught cell is nothing but equal to 0.0591 divided by N, and this is nothing but log Kc. So this is the formula what we have, that is E naught cell is equal to 0.0591 upon N, and this is log Kc. Can anyone calculate the value of N in this question? What is the value of N in this question? Anyone? What is the value of N? That is number of electron transferred per mole. Yeah, I got one response. JNB Bahraj A. अच्छा, A तुमने बोला है correct answer, right? Okay, beta. Let me check, right? Can anyone tell me what is the value of N in this question? N. I'm waiting for the value of N. Yeah, 2. Very good. So the value of N is 2, right? That is 2 electrons is transferred in this reaction. Very good. So the value of N is 2. So we can put the value like 0.0591, and the value of N is nothing but 2. And this is log and this is Kc. What is the value of E naught cell? So value of Kc is already given now. So just put the value beta. So that is 0.0591 divided by 2. This is log. And what is the value of Kc? That is 10. Already given 10 into 10 raised to the power 15. So this is 10 into 10 raised to the power 15. Okay? So this is 10 into 10 raised to the power 15. Just try to solve this question. How will you solve this question, beta? We know this one solving, you'll get 0.0295. How will you solve this log value? This one is very interesting. So we can write this value like this. This is log 10 plus log 10 raised to the power 15. Because we know the property of log, log m into n written as log m plus log n. So this we can write as 0.0295. And this is log 10, we all know, plus 1. And this is 15 log 10. Again, log 10 value 1. So on solving, what you will get, beta? We'll get 0.0295 multiply 1 plus 15. That is 0.0295 into 16. So this is the final answer what we get. So on multiply, we get is 0.473. So this is the correct answer. So which option is correct? 0.473. Yes, 0.473 volt. Right. So option A is absolutely correct. तो सबसे पहले कितने रिस्पॉन्स किया था? दैट इज JNV बहरौच. वेरी गुड बेटा. सो बिल्कुल करेक्ट किया था तुम लोगों ने, है ना? गुड. So this is the correct answer for this question, right? So such type of questions were generally coming in your examination where you're preparing for your JEE examination, mains examination, advanced examination, or for your NEET as well, right? So these type of questions generally coming. So try to learn the formula, try to, solve many questions as you can, so that you can able to know how to apply the step-by-step solution for the any question, right? How will you able to identify which value is given, which value is needed? So if you know the concept, if you know the formula, and you know some little bit solving capacity, then you can able to solve each and every question, right? So now I'm going to provide you a homework question for you all, right? So this is the homework question for you all. So try to solve this question, right? Try to solve this question. This is the question number 1. Please note this question, right? So if for the half cell reaction E naught values are given, calculate E naught value of the cell reaction like copper to E, that is copper, right? So this question is very much similar to the previous questions, right? We discussed what happened when we have the oxidation reduction potential value changes from +2 to +1, +2 to +3, like this, right? So this is the homework question for you all. Try to solve this question. Anyone having any kind of doubt till you can ask me. किसी को कोई भी डाउट है आज की सेशन में, आज की क्लास में कुछ भी पूछना हो, so you can ask बेटा फटाफट. No? Everything is clear? Response दो फटाफट बेटा. Everything is clear? Or anyone having any kind of doubt, you can ask. Last 1 minute is left, so you can ask your doubt. No, I hope all things are very much clear, right? Chalo, very good. So try to solve this question and try to revise all the important question of this chapter. Try to solve much more questions related to this electrochemistry, because this is the important chapter of the physical chemistry, and this chapter generally consists of numerical portions only, right? So try to solve good level of questions, which include both the like type 1 level, type 2 level. In your modules also the questions are given. So try to solve question from your module. ठीक है, और इसको अच्छे से सॉल्व करो, देन यू विल बहुत इजी लगेगा ये चैप्टर. सो ऑल टेक केयर, मिलते हैं नेक्स्ट क्लास में. देन वी आर गोइंग टू डिस्कस द केमिकल काइनेटिक्स पार्ट्स, राइट, एंड some important question related to this chapter also, right? So till take care all, goodbye.